So our final speaker today is Dr. Maria Loza, who's a postdoctoral fellow at head office in Dr. Sandra Ramirez's lab. And today she will be describing bacterial contamination of platelet storage bags and the impact to patients of bacterial attachment to the surface of platelet bags.
Thank you everyone to be here. I'm going to present the results of this study entitled Bacterial Attachment to Apheresis and Buffy Platelet Storage Bags. And I conduct this study together with other colleagues and under the supervision of Dr. Ramirez. There are no conflicts of interest to declare. And to start, it's important to know that platelet concentrates used for transfusions are susceptible to bacterial contamination, and this is due to their storage conditions in gas-permeable plastic bags containing a glucose-rich additive solution at room temperature under constant agitation. Bacterial contamination represents the greatest post-transfusion infectious risk, and fatalities due to contaminated PC transfusions are reported every year worldwide. So when there is a PC contaminated with bacteria, Staphylococcus epidermidis is the most frequently isolated aerobic bacterium. But where does this come from? This bacterium is part of our normal skin flora, and it is also an opportunistic pathogen. So that means that it can be harmful for the human. Its pathogenicity comes from its ability to form surface-attached cell aggregates known as biofilms. When a bacteria finds a solid surface to attach to, and they start to accumulate, when they are a good number of bacteria, they can produce a matrix that will protect them from stressful environmental conditions, but also from antimicrobial agents such as antibiotics. This ability to form biofilms allows them to be the predominant contaminant of implanted medical devices. Importantly, this bacterium can adhere to the inner walls of the PC collection bags, forming biofilms and hiding, as opposed to be floating in the PCs. So as a consequence, this might increase the chances of misdetection during PC sterility screening. At Canadian Blood Services, as you may know, PCs are produced by two different methods. Apheresis, this is a single donation of platelets suspended in plasma, and pooled platelets. This is 4 platelet fractions or Buffy coats suspended from 4 donations suspended in the plasma from one of the donations. Both PC types are stored in PC collection bags from different manufacturers. Both are made of the same plastic material, mixed with the same plasticizer. Details of the composition of these bags are not completely known. And because of the frequent problem of bacterial contamination, we wonder how is bacterial attachment to the PC collection bags influenced by the presence or absence of PC residual material. So the objective of this study was to evaluate the ability of S. epidermidis to adhere to the PC collection bags with and without the presence of PC residues. So for the experimental design, we used sets of bags. 2 of them were obtained after draining the residual PC product, one from apheresis and one from a Buffy coat PC, and we named them PC coated bags. We then wanted to test the absence of platelets, so we needed plasma coated bags. For this, we took 1 apheresis and 1 Buffy coat bag. We filled them with plasma, and we incubate them for 24 hours. Then we drain the residual plasma product, and we obtain the coated bags. We also include empty bags from our collection kits, 1 apheresis, 1 Buffy coat bag, and we call them uncoated. Then we fill the bags with 200 milliliter culture medium containing low levels of bacteria. We incubate them for 7 days under PC storage conditions, and on day 7 we analyze the bacterial attachment. What we did was to discard the supernatant, we rinse the bags, and then we dislodge the attached bacteria and determine the bacterial levels. In parallel, we prepare bag coupon samples for microscopy analysis to confirm bacterial attachment. What we have found. First, we look at S. epidermidis attachment to PC-coated bags. What you can see here is the bacterial levels from apheresis compared to Buffy coat PC-coated containers. what we see is that bacteria adheres equally to both bag types. Then we look to bacterial attachment to plasma-coated bags. Again, the bacterial levels in apheresis compared to Buffy-coat plasma-coated containers show that bacteria adheres equally. A statistical analysis of these two conditions shows that there is no significant difference between PC and plasma-coated bags. Then we look at uncoated bags. Bacterial levels recovered from apheresis compared to Buffy coat show a difference, and this difference is significant, and it's higher in apheresis, uncoated bags. Then we compare coated versus uncoated bags, and what we found is that the difference that we see is significant and is lower in uncoated bag compared to the coated condition. We performed the same experiments on two different S. epidermidis strains, and what we have found is that there is no significant difference between the strains in the way they attach to the bags across the different conditions we have tested. Finally, the scanning electron microscopy of the samples that we recovered from the bags show and confirm that bacteria is attached, and we found them during early stages of biofilm formation. What you see here is an increasing magnification of an apheresis and a Buffy coat PC coated bag sample. In summary, from this study, in presence of PC and plasma residual material, bacteria adheres equally to bags independent of the PC type and the bag type, and bacterial attachment is significantly higher in coated bags compared to uncoated ones. In uncoated bags, bacterial adherence is higher in apheresis than in Buffy coat bags. In conclusion from this study, we see that the ability of S. epidermidis to adhere to apheresis and Buffy coat PC collection bags depends on the presence of plasma residues coating the bag. So it is known that plasma proteins can be absorbed to different plastics of medical use. So we even went a step further, and we tried to select one of those proteins from plasma and remove it. So we selected fibrinogen. We tried to see if we saw reduction on bacterial attachment by removing it from plasma, but we didn't succeed. Still, this study shows evidence that plasma residues attached to the PC bags might serve as a scaffold for bacterial adhesion, leading to biofilm formation. And importantly, difference in the PC storage bag types, but also PC types, should not represent a threat for quality and safety of PCs, and therefore efforts should be focused on reducing plasma residues attached to the PC containers. I will thank you for your attention. I'll be happy to answer questions, and I just want to thank also our colleagues from NetCat for providing us the platelets, donors, Craig Jenkins, because he always provided me all the bags I needed for this study, and Mariam Taha for characterizing one of the strains.
Thank you very much. Are there any questions here in the Alberta room? So if you were to continue characterizing what it is in the plasma that might be contributing to the differences in adherence, what do you think it is in the plasma that could be causing the effect you see?
So for bacterial attachment, well, it could be a combination of different proteins there, and maybe the removal of one of them wouldn't have a significant effect on reducing bacterial attachment. So for this, we have thought that what we could do is to prepare serum and try again the experiments just to see if we can actually see the reduction of bacterial attachment.
So thank you very much, Maria. It's a great talk.